here. I don't think I did. Nope. Okay, so I'm going to go to the textbook. All right, and we've been working on chapter 8. Let's see what's in chapter 8. Solutions, dilutions, electrolytes, acid base. That still is not a very long list. There are more strong bases than that. Give me 1 second while I look it up in another textbook. Wish we were still using the textbook we used to use. It just felt more comprehensive. Here, I'll share the page so that you are not just sitting there waiting and waiting and waiting. I think it would be this page. Okay. Let's go to solutions, maybe. Acid base. Ah, there we go. Here, well, that doesn't tell whether it's strong or weak. Okay. Well, maybe it does. Okay, yeah, this one is pretty good set. Can you see what I'm showing on the screen?
Yes, ma'am.
Okay, so this is a pretty good list. So it's got 1, 2, 3, 4, 5, 6, 7. So it's hydrochloric, hydrobromic, hydroiodic. So it's hydro with all of the halogens except fluorine. And then you've got nitric, sulfuric, and perchloric. And those are all the strong ones that you would need to know. All of them that I can think of at the moment. If you need to know some more, I will let you know that. And then there's acetic acid is weak. That one's easy to remember because acetic acid is smells like vinegar. And to me, vinegar seems like a weak cleaning solution. It probably isn't, but it just feels that way to me. My landlord only lets us clean the floor with vinegar, which is why I always think that, because I'm like, oh, can't I use Pine Sol? But she's really particular about her floors. And when I'm all done, the house smells like vinegar instead of like lemons. It drives me nuts. But that's beside the point. Okay. And then hydrofluoric acid is also weak. Now, if you look at the ones that are the bases, look and see the pattern for all the strong bases compared to the weak base. What's the pattern?
They're either in group 1 or group 2.
Yeah. What else?
Well, are you asking if it has OH in the end?
Yes.
Okay.
That's it. So if you see an OH, most of the time it's a strong base. The only weak base that I can think of that you really need to know is ammonia. Do you need a second to write these down or take a picture?
Oh, no, man. I found them in the book. Yeah.
Did you? Okay. Is it is it the same ones in the textbook?
The one I found was, the PowerPoint you posted in the alternative, in the PowerPoints in the study resources.
Uh-huh.
That's the same as this one.
Oh, good. All right. I thought I had posted some, but I couldn't find them when I was looking. So.
Yeah, this is the same one.
Okay. Cool. So those would be the ones that you'd need to know. Okay, so Stephanie wants to do a base redox problem. Yes. Which class are you in? Are you in 10 o'clock or 11 o'clock class? 10. Okay. The reason I was asking was because I did one like crazy fast in the 11 o'clock class. Probably faster than I should. I mean, definitely faster than I should have. I just had a few minutes left. But I didn't want to bore you with doing the same example like 7 times. So I can use the same example. Yay. But let me find it. I think it's section 19 in this textbook. 19.2. All right. Let's do. All right. Iodine, MnO4 minus. All right. Let me find. Oh, goodness. Let me find what I did with the whiteboard. Okay. So we've got S plus MnO4 minus makes I2 plus MnO2 solid. All right. So that's going to be our general equation for this example. And this one is going to be in a basic solution. And I'll put that over here to the side. When I say basic solution, I don't mean like a simple solution. I mean like there's a base as opposed to an acid in it. So the first part is just like we would do in all of the other equations. You're going to assign oxidation numbers. So we'll do that. Should do them in green. All right. So for I minus, it's a monatomic ion. So according to the oxidation number rules, it's just going to have its charge as its oxidation number. It's going to be on -1. And then permanganate or MnO4 minus is so there's. I can hear my husband talking in the other room on the phone. It's driving me nuts. So manganese is a transition metal, and there aren't any rules for manganese because it's a transition metal. So the only thing that we have in this compound that we have a rule for is oxygen. And the rule for oxygen is that it's always -2 unless it's in a peroxide, in which case it's -1. And they generally have to tell you if it's peroxide, unless it's H2O2, in which case they expect you to know that's a peroxide. So we'll calculate manganese here in just a second. Now, I2 is just an element. It is aqueous, which makes it look a little strange because normally I2 would be charged if it was aqueous. But in this case, it's just a molecule floating around in water. So we're going to count that as just being in elemental form because it's just an element. So we're going to give that a 0. And then over here, we've got the same problem with manganese. So we're going to assign oxygens, oxidation number. So over here to the right, we're going to calculate MnO4 minus. We're going to calculate the manganese for this one. So it's manganese plus 4 oxygens equals -1. Now the -1 is coming from this negative charge right there. So the whole thing has to add up to whatever the molecule or ion's charge is. So far we've been using a lot of neutral stuff, but in this case it's an ion. So all right. For oxygen, we assigned it a -2, so we got manganese plus 4 times -2 equals -1. And then we've got manganese -8 equals -1. All right. And then we're going to, why did I put a 9 there? Did I see that? I don't know what, like, I hope I just hit the 9 button. I wasn't like, 4 times 2 is 9. Okay, manganese -8 equals -1. That looks prettier. All right, we're going to add 8. We're going to add 8 to both sides. All right. Okay. And then what we have at the end is manganese is +7. All right, so we're going to put +7 over here. Bring this down a little bit. Okay. Now, manganese is a transition metal. It's not always +7. So we're going to look at the other one, the manganese oxide, the MnO2. And it's neutral, so whatever these add up to has to be 0. So it's manganese plus 2 times whatever oxygen is equals 0. All right? And then, so it's manganese plus 2 times, and we assigned oxygen as -2, equals
Kelly?
0.
Professor Kelly?
Yes.
Is it equal 0 because there's no charge at the end? Is that correct?
That is correct.
Okay.
That's why it equals 0.
Okay, thank you.
You're welcome. All right, and then we've got manganese -4 equals 0. And then we're going to add 4 to both sides. Okay, and then I'm going to draw a line here. I don't know if my husband could get any louder if he tried. Driving me absolutely up the wall. It's like I'm off teaching a class. Be quiet. Okay, I need patience, right? Patience. Okay, so there we go. We've got manganese this time equaling +4. And notice, hang on, I'll show you what I want you to notice. Okay, notice that with the manganese, he's so distracting, it's making me crazy. I'm sorry guys, I'm trying to think and all I can hear is his voice in the background. Okay, so with manganese, with oxygen, we've got 2 oxygen in MnO2. We don't put -4 as the oxidation number. We put -2 because we always just want to put the oxidation number of just one of them. Okay? And that's going to bug me. Okay, so now, anybody have any ideas as to what the next step is? Let's see. Oh, and we can do an acidic. Yes, Coralie, we can. Can't speak, but I can do it. I would be glad to do one. All right, so I'm going to tell you the next step. The next step, what we're going to do is we're going to separate the half reactions. All right? You're welcome. I need to move this out of my way. There we go. When I click on the chat box, it always pops up right over the whiteboard. Okay. And then I need my tools back. Come here, tools. Okay. So one of the half reactions is going to have the iodine and the other one is going to have the MNO whatever. So I minus makes I2. And I'm going to go back to here. Okay, so there's one half reaction. Now we're going to do the other half reaction. MnO4 minus aqueous makes MnO2 solid. And you may wonder, why is it solid if it's in an acid? I mean, if it's in a base. And the reason is because sometimes you have solution, and so it falls to the bottom. Kind of like if you did you guys do a copper experiment in your lab this semester? So you saw the copper just kind of fell out of solution. That's a precipitate, and that's the same thing that happens, that apparently happened with the MnO2. It just kind of fell out of solution. All right. So now what we're going to do is we're going to make sure that there are enough of everything on either side. We're going to wait to balance any hydrogen and any oxygen. So I'm going to put that at the top. Okay. So let me change colors again. All right. So if I look at the I2 on the right, how many iodine do I have there? 2. The I minus, how many do I have there? 1. So I need to put a 2 in front of it. That way I'll have 2 of them. All right. And then looking at the one below that with the manganese, how many do I have on the product side? So that's the right-hand side. How many on the left? 1. Good. So those are balanced, and we're waiting for the oxygen. Now, most of the time we have not done this step, and the only reason we haven't was everything just was naturally balanced already. Like when we had aluminum solid goes to Al3+, those just had 1 aluminum on each side. It was still a step to balance them, but they were already balanced. So we just went on to the next part. So now that those are balanced, we want to balance the oxygen. So I have 4 oxygen on the left and 2 on the right. So I have to add some water. If you look at the formula for water, how many oxygen are in a water? So it's good. So it's H2O, so there's just 1 oxygen per water. So if I have 2 oxygen in MnO2 and I need 4, how many water molecules will I add? 2 plus blank equals 4. 2. Good. All right. One thing to keep in mind when we're doing this, we're not like adding water to a solution as if we were in a lab and we had MnO4 minus in a container and we added water to it. This is not the same thing. This is actually what's in the solution when it is a base. We're just describing when it's a base and we have this, what is in the solution. we're not adding things to it here. All right, I need to put a plus sign. That would be nice. Come on. Okay. So now I see that the oxygen is balanced. But what is not balanced now? The hydrogen. I have 2 hydrogen on the right and 2 hydrogen on the left. I'm going to put it down here to balance hydrogen, put H plus on the other side. Okay. So I have 4 hydrogen in these 2 waters total, because 2 times 2 is 4. So I need to add 4 H plus over here. And I need to move it so it can be seen. All right. So now this is all you do if you're doing an acid reaction. At this point, you'd be like, done, and then you would add the electrons and everything else just like the normal ones. But this is in a base. Since it's in a base, we want to neutralize the H plus. With OH minus. Okay? So how many OH minus would I add to neutralize 4 hydrogen? So if I have 1 acid and 1 base, what happens? They'll cancel. They'll neutralize each other, correct? Let me move this stuff over a bit. Hang on a second. Trying to just grab this guy over here. Not just the plus sign. Come on. Okay. There we go. All right. So we're going to add 4 hydroxide because we have 4 H plus. All right. And again, I put it all crazy. Oh, I still have my caps lock on. Okay. But we can't just add it on the left like we did with the hydrogen. We have to add it on the left and the right. Okay. Let's see if we can kind of wrap this a little bit over. Just a hair. Okay. So let me put that in the steps down here. Add OH on both sides. Once the OH minus is on both sides, we're going to combine all of the H plus and OH minus as long as they're on the same side. Right? They're going to combine to form water. Because that's what would happen. The H plus would be attracted to the OH minus, right? And those would just come together and make water. Right? So we're going to do that. We're going to write 4H2O, that'll be liquid, plus MnO4 minus aqueous makes MnO2 solid, 2H2O liquid plus, ooh, I made an error there, 4OH minus aqueous. Anybody see what error I made when I was adding the hydroxide in the equation above the one we're working on now? I have 4 hydroxide on the left and 1 on the right. That's crazy, right? I need to have 4 on the left and 4 on the right. Okay, so that should have been 4 hydroxide right there. All right. Now, I want to add the electrons that I need. All right. So to do that, I need to look at the thing that's changing oxidation state. In the iodine one, there's only one element. It has to be iodine, right? Because it goes from iodine 1 and then it's got a 0. So which side is more positive, -1 or 0?
Zero?
0. Good. So on the left, it looks like I've got a -1, but I do have 2 of them. So I'm going to have to cancel both of the -1s. So that's why I'm going to add 2 electrons on the product side. Okay, so I have I2, which is neutral, plus 2 negatives. So it'd be like 0 minus 2. That's going to be -2 on the right. And on the left, I have 2 times I minus, so that's also a -2 on the left. So on the left and the right both match now. All right, let me move this to plug in. Okay, so with the water and manganese and everything, the H, all of the H's have a +1 as their oxidation number. All of the oxygens have a -2. So the H's and the O's don't really matter as far as when we're trying to count up how many electrons to add. So what we're going to be looking at is we're going to be looking at the manganese. Over here, we said it was +7. And over here, we said it was +4. That's what we did up here. So this was a +4, and this was a +7. So we're trying to figure out how to make them equal. We always add on the more positive side. All right, so which is the more positive side? The reactant side or the product side? Good, reactants, because it has a +7. Now, how many electrons would we have to add to +7 in order to get +4?
Yes.
3. Good. Okay. So now, looking at these two, let me get rid of this. There we go.
Yeah.
Come on, go away. There we go. All right. Looking at these two, we're going to add them together. But we can't add them together just yet. What did I do with my electrons? They're gone. Let me put the electrons back. I must have accidentally erased them. Sorry about that. There they are. They're back now. All right. So I'm looking at the electrons. The manganese half reaction has 3 electrons, and the iodine half reaction has 2 electrons. Oh man. It's saying that I have less than a minute left, so it may close. If it does, we'll reopen it, and then you just come back.
Oh.